again. So this time we'll be treating another physics past question on the topic moments, that is equilibrium of forces. Now the question says a uniform meter rule AB is pivoted at its midpoint K with a vertical force of 12 Newton hanging at point X. That's 15 centimeter for A. At what point must a 15 Newton force be hung to balance the rule horizontally? So we have some options, 15 centimeter from K and so on and so forth. But first of all, let's have a glimpse of what it looks like. Question like this, you always come up with a diagram. So this is our meter rule. Now when they say meter rule is one end of it is 0 centimeter. And of course, the other end is 100 centimeter. We have that in mind. They say let's call it AB. So one of the end is A and the other end is B. Now, when they say meaningful, a meter rule is uniform, one thing comes to mind as far as every student of physics is concerned. It means it will balance at the midpoint. That's 50 centimeters. So quickly locate your 50 centimeter mark. And they say that is where it balances. You put a pivot at its midpoint. So we put our pivot there. And let's call it K. Now they said there is a balance, a vertical force of 12 Newton hanging at point X. Now where is point X? Point X is 15 centimeter away from A. So let's go to A. Let's call here 15 centimeters. At that point, we put our point. We'll call this point X. At that point, let's put the force of 12 Newton. 12 Newton. Now the one who've presented the information, it is uniform. So it balances at its midpoint. Meter rule is 100 centimeter. At the midpoint, we put a pivot of it. At the midpoint, we put a pivot. Then we put a force of 12 Newton at point X. Now they are asking us which point are we going to put another 15 Newton force for it to balance. Now, first of all, we have to use our normal thinking. Of course, if you have something like this, like our seesaw swing, if somebody sits on one end, of course, for it to balance, another person has to sit on the other side of it. So that means our 15 Newton force is going to be somewhere here. But where's the exact position? We don't know. Now, the question now says, at what point will it be for it to balance horizontally? So at this point, we'll now bring in some of our principles of this topic. Now, the first principle says, if you have a force on this side, of course, if somebody is to pull this force, it will swing on this side. And this moves like the hand of our clock. So we'll call this clockwise moment. Now, if they are to pull this force here, of course, it will move on this side. Now, the one that moves opposite the direction of our clock moves like this, but this moves like, we'll call it the anti-clockwise moment. Now, the main principle we are using in this topic says that your sum of clockwise moments should be equal to your sum of anti-clockwise moments. And what do we know moment is? Moment is every force times the distance that is perpendicular. So if the force is vertical, then the distance from the pivot should be horizontal. So for this one, the force is vertical 12. Now the distance from the pivot, if this is 50 and this is 15, that tells us this distance from here to here is going to be 15 minus 15, and that's 35 centimeters. Now for the second force, the force is 15, and this is the distance that is perpendicular to it. So this point we don't know, so let's call it x. So quickly, for the clockwise moment, we have 15 times x, 15 times x, and for the anti-clockwise moment, we have 12 times 35. So the principle says both should be equal. So 15 times x. So if we solve this, this is going to be 15x equal to 12 times 35. And of course, if we divide both sides by 15, that means 5 is going here 3 places, 5 is going here 7 places, 3 is going here 1 place, 3 is going here 4 places. That means x is going to be 28 centimeter. Now, if this is 28 centimeter, and of course, don't forget that this is 50 centimeter. That means, and this place to this place is 50, here to this place is 50. That means the remaining distance here is going to be 50 minus 28, 22 centimeters. So if we check our option again, the option says A, it is 15 centimeter from K. That's not true. B says it is 22 centimeter from K. That's not true. C says it is 28 centimeter from B. That's not true. D says it is 63 centimeter from X. So let's check X. That is 28 plus 35. And of course, that's going to give us 63 centimeters. So that's the correct answer. So therefore, we say the force 15 Newton is what? 63 centimeter from X. So you can see the different ways the option came. So take note of the principles we've applied. First principle we've applied is moment is every force times the perpendicular distance from the pivots. This is our pivots. Secondly, a force that will draw it this way is called a clockwise moment, and the one that will turn it this way gives us the anti-clockwise moment. Your sum of clockwise moment should always be equal to your sum of anti-clockwise moment. A uniform meter rule, of course, a meter rule is 0 to 100 centimeter, but when it is uniform, it will always balance at its midpoint. So take note of all these principles as we look forward to another of our videos. Watch, like, share, and subscribe to get more. Thank you very much.